speaker is Aurelie. Aurelie is Shapiro is a chief scientist or chief technical advisor in the Food and Agriculture Organization of the United Nations. 20 years of experience in remote sensing for conservation and spatial analysis. Aurelie is an experienced drone pilot and cartographer. She's working toward a PhD in geomatics from Humboldt University in Berlin. Aurelie obtained her master in environmental management from Duke University and the Bachelor of Science from McGill. She started her career as a marine remote sensing. So women are amazing. She's not scientist only, but she's someone amazing. Where she used her high resolution satellite skills, followed by 14 years with WWF, which is the Worldwide Fund and the Worldwide Fund in Nature, working on marine terrestrial conservation projects around the globe. Currently, Aurelie is tackling a new challenge with the Food and Agriculture Organization of the United Nations, working on a global project to evaluate the driver of the deforestation and degradation with satellite remote sensing. So please, I welcome Aurelie and help me to welcome her. She will be talking about quantifying the drivers of deforestation and degradation from space. The floor is yours, Aurelie.
Great. You can all hear me now? Thank you for having me for this really interesting presentation. I'm lucky, I guess, to go first and being followed by a lot of interesting speakers after me. So yes, I'm going to share with you today a little bit of information about the project I'm working on for the FAO, which is supported by CAFI, which is the Central African Forest Initiative. And the goal is to quantify the drivers of deforestation and degradation from space. So what does that mean? So we all know that forests are very, they're important. They're crucial to the livelihoods of millions of people. They store carbon. They provide habitats for biodiversity. There's really a number of values of forest. Unfortunately, we see them throughout the world being burned, cut down, degraded, and deforested. So to basically combat this challenge, and in particular right now, which is the COP26 in Glasgow, we are developing new methods and tools to detect deforestation and degradation, and most importantly, the drivers associated with these changes. So why are we losing forests? Is it because of agriculture, mining, roads, infrastructure, things like that? And we're developing new methods, mostly using satellite imagery, but also open source software, so completely open, accessible tools. So the objective of the project is to evaluate trends in deforestation and degradation in Central Africa from 2015 to 2020. And we're identifying and quantifying these drivers of loss and disturbance, so what the associated causes. And this information is developed to provide new decision support tools and basically better land use planning. So the strategy of PRIDE is basically that we want robust and transparent and reproducible methods that we can use in other places in the world. And most of all, it has to be open source, so people can easily copy or reproduce the approach. We're partnering with academia and civil society and a lot of all the governments and ministries in the different countries we're working. And finally, it's a lot of capacity development. So we're actually training people, teaching people how to use these methods, and basically perform the analysis themselves. So we're working in 6 countries, which is pretty big. We have the Democratic Republic of Congo, which is the largest, holds the largest piece of forest in Central Africa, Republic of Congo, Gabon, Equatorial Guinea, Cameroon, and Central African Republic. So it's a very, very large study area. And the methodology, like I said, it's transparent, it's reproducible, and it's open. And it's using what's called FAO's CPAL platform, which is it's an online platform to basically ingest and analyze satellite imagery and perform a number of advanced analyses, including machine learning and some AI. The benefit of the system is that it's agnostic to data type. That means we can use a number of different kinds of satellite imagery. We're not limited to only a few sources. And a lot of this is supported by the Norwegian NICFI, KSAT, Airbus, and Planet, which are providing additionally high-resolution data to help us with our project. So the most important thing to consider in this work is how we define deforestation and degradation. So you've all heard of deforestation. It means, when you cut down trees and you're converting these forests to another land use. This is a pretty standard definition. However, degradation is usually less well defined, and it's more of a temporary or maybe a more subtle change in forest, which is generally harder to detect. And that's really the innovation of our project, is that we can tell you where forests are really being lost and converted and deforested versus forests that are maybe just being degraded and could potentially recover. So the most important thing to consider here in Central Africa is persistent cloud cover. The video on the right is actually the cloud cover, monthly cloud cover, as you can starting in 2002, which is basically persistent over the region. So when we're using satellite imagery, so we're looking at things from space, clouds are a huge problem. So we need to overcome this. And we do that by basically combining many different images to try to remove clouds and shadows and provide a clear view of the forest. So let's pause that. Next slide. So what that means is we basically combine, using SIPAL, we combine thousands and thousands of different images, maybe over the course of a year, to provide these cloud-free mosaic like you see here with the image on your left. And that is actually combining different satellite sensors. So we have satellites from the US, so the Landsat program, combined with Sentinel data, which is from the European Space Agency. And we combine them to provide these really nice images that essentially have practically no clouds. Maybe some little places in Gabon, but basically we have a cloud-free image. And then in addition to that, we use another type of satellite data, which is called active radar. And this is a satellite data that can actually penetrate clouds. It's a different kind of sensor. And we combine that with these images to really provide the best images we can get to map the forest. So once again, just following on this is showing you these different satellite sources. And you can see where we have different types of holes in 2015. And essentially what we're doing is we are creating a baseline map for 2015. We want to see what kinds of forests are there, what is present, and then the changes from 2015 to 2020. And we use different types of change or different types of images to assess the change. And that's where the CBAL tool comes in. We can identify forest types. So we have 4 different images here. On the lower right, it might be our image mosaic that I showed. And then alternative sources, for example, the top right is the planet data, higher resolution. And then on the left is our map of forest cover types. So we're identifying primarily what kind of forest is present in 2015, if it's a tropical forest or a dry savanna, or in this case, water or a swamp forest. Because that's going to be important in terms of determining what kind of change we're seeing. Okay, and then for every single pixel at this entire scale, so I don't even know if I can count how many pixels it is, but it's probably on the order of billions. Every single little pixel, so every single 30-meter square area in the region of the 6 countries is analyzed from 2015 to 2020. And what you have is, for example, this trend, or this profile of that pixel. So this area, for example, on the left, is changing a little bit and slowly going down. That might be an evidence of degradation. So it's just a subtle change in forest cover. Whereas on the right, we have an example of deforestation, which is you see an abrupt change in the characteristic of the pixel. So this area might change a little bit, it becomes green and brown in terms of rainfall, but then all of a sudden we see a drastic change, and that's probably is because it's been cut down or converted to agriculture or something else. So we pull out these different, let's say, trajectories or histories of each pixel to identify what is deforestation and degradation. And it's a massive amount of processing, all performed on Amazon Web Services through CPAL. So when we come up with this map of change, we have areas that we believe are deforestation and degradation, and we sample them. We throw a number of random plots on the map, and what we do is we have people go and assess these areas visually. And this is where AI could actually probably play a really important role, because this is a very tedious process. We have 30 technicians in all 6 countries, and for every single one of these 11,000 points, they go and they look at a high resolution image and they try to identify what is the driver. So in this example, we have, let's say, logging roads on the bottom, and small scale agriculture on the top. So basically, all of our technicians are right now doing this validation process to visually, determine what is causing the change, or what is associated with this change, and whether it could be mining or villages and so on. And what that gives us in the end is basically what we have now in these preliminary results. So for what I can show you on the left is that we have different types of forest, and in each of these different types of forests, we have whether we are observing change or not. What type of change has been observed, since once again, this is all visual now. Looking at deforestation and degradation together, deforestation or degradation, and then the year of change. And what we're seeing, and this was presented preliminarily last week at the COP, is that we're actually noticing that there might be a decrease in deforestation over time in the region. Now, this is really important. Of course, the deforestation and degradation is still occurring. It's still drastic, but there seems to be a trend of decreasing. And we're not exactly sure why, or why there was this peak in 2017. It could be associated with El Nino, or the drop into 2020 could be associated with the pandemic. We're not really sure, but we're definitely exploring this in more detail now with more information. And the image on your right shows you then for each type of change, so the deforestation versus degradation, deforestation together versus degradation, what types of drivers are primarily associated. So we see that what happened here is small scale agriculture is pretty much by far the largest, let's say, associated driver with change, followed by roads. And then we have different types of forestry. So it could be small scale forestry activities or large scale forestry activities. And what's important here is that these drivers actually occur together. So we're looking at areas where you have roads with other types of drivers, or mining and roads together, to really pull out, these different drivers, because it's not as simple as it sounds. You can't just say a road is the cause of deforestation. You have to look at, what is that road used for and what follows next. And the policy implications here are really interesting, because if we look at, let's say, the region, and this is an example from previous studies, is that we can see, what kind of causes what kind of causes are removing forests or affecting forests, and that will help you determine, what types of interventions should be done. Should we be implementing new agricultural mitigation activities? Should we be looking at how roads are developed? And so on. So this really affects at a higher level what kind of investments will occur, and what kind of activities we'll be engaging with to reduce deforestation, especially in light of the commitments that were recently made in Glasgow. You might have heard by 2030, there is a global goal to stop all deforestation. So we really need to know what is happening where in order to slow these change. And just one thing I wanted to share is that because of the pandemic, a lot of this work is all being done online. And we have bi-monthly webinars with a really big participation. And of course, through our donor, we do look at the gender ratio of all of our participants. And it's pretty nice to see a nice female representation, upwards of 30% in all of our webinars and our activities, which is really good to know that we are training the next generation of female remote sensing specialists. So all of this information is shared. We provide it online, recordings and so on, and we're really encouraging new people and new analysts to uptake the information and to really learn what we're doing, and and build on this and develop their own capacities and improve their own knowledge and abilities. So once again, we have a lot of coordination and communication tools. So we're using primarily Zoom, which is really great. We have Slack, but actually the most fun are we have these WhatsApp groups. Every country has its own WhatsApp group, and we're constantly chatting and sending around emojis and animated GIFs and stuff. And it really makes it, I think it provides a lot more of a personal touch in terms of, being on these online, invisible platforms. We really have a great time with everybody on the project. And we also use the Google Classroom, which is also another resource for giving people homework and assignments and kind of tracking their learning. That's another aspect of the project I like. And I encourage you to look at our website. Of course, it's all in French, but I'll share it in the chat. But basically, everything that's developed for the project is shared online. The methods as we go, the webinars, the data. We have interactive maps and so on. It's all developed on this living website. And we also have friendly competitions. For example, here we have on the top right, we're competing to see who can validate the most points as those driver visual interpretation I showed you on identifying drivers. So we have people who kind of win prizes and can excel in the number of points they do, and it helps really encourage the work to continue along. And that's all for today. Thanks for having me, and thanks for listening to my presentation, and I look forward to the panel discussion later.
Thank you, Aurelie. Thank you very, very much. So we'll probably use your time, probably 10 minutes, just to see if we have any question from the audience. The floor is for everybody. So if you have any question, Aurelie is here to help to answer them. Please go ahead. Meanwhile, what we can do, while waiting for the question to be received here, I have a couple of questions, Aurelie. It was very interesting discussion because I have never been attending a talk about the degradation of the forest. Since it is something that is related to countries and continent, because you gave the example of Congo, Republic of Congo. Do you think that from a political point of view, is there any different mechanism used for the awareness about conserving and avoiding degradation, since there is a cultural thing that is involved, like the population, their behavior toward the forest, etc.?
That's a really great and really relevant question, and that's actually something that came up last week at our presentation at the COP. Of course, we're finding out that, let's say, small-scale agriculture is a major driver, right? People need to eat. People are poor. The situation is really difficult. People do what they can. And I believe there was a statement also is like, empty stomachs don't have ears. So if someone is starving and trying to feed their family, they're not going to listen to you if you tell them that forests are important for climate, or forests, have wildlife in them and things like that. So I think what really this helps us do is address like the root issues. And for me, and that's why I really enjoy being part of the Food and Agriculture organization, is that I think, part of the highlight of the organization is really teaching people how to grow better crops, to be more sustainable, to grow forest-friendly agriculture, and to really, help them improve their livelihoods. And I think that's going to be the biggest issue, especially, I neglected to mention the population is increasing very quickly in the region, up to 6% in some of these countries. So there's going to be more mouths to feed, affected by climate change, affected by all these issues that we really need to address. This root cause of, you need to have people be healthy, have livelihoods, and be able to feed themselves.
Yeah, very interesting. And I have also some, I hope I will not, take advantage of you today, but it's a golden opportunity, really. So from technical point of view, so there are two things. One, in your area of expertise, since you are talking about collecting data from using sensor, etc. From your experience and your team, what is where do you spend time? Is it in the data acquisition, or is it in the data analysis? Because it's different data that we handle every day, for example, in data science.
Yeah, great question. So I believe there's a lot of tools now that improve our access to satellite imagery, right? There's, I use Google Earth Engine, we use the CPAL tool. So the data acquisition for satellite imagery, that part is becoming much shorter. But it means that there's a lot more time on the data analysis, and that's exactly what it is. For example, interpreting these results also. What does it mean when we have, small-scale agriculture is the most common driver? Where is that happening? Why? And we're actually becoming, more time is now into like interpreting these results, and also making them understandable for people, understandable for policymakers, for the general public. And that's actually taking up more of our time. And I will say, because there's been so much talk about artificial intelligence, that step I was telling you, where we have points and we look at the data and we identify the drivers, that unfortunately is taking 3 times as long as the actual data analysis. So we processed billions and billions and billions of pixels, but at the end we have this very manual, tedious approach of identifying drivers, and it's taking forever. And it's delaying the whole project, and it's unfortunate, and that's, I think, where AI can play a huge role and really help us, hopefully in the future, make that more automated.
So I got some question from the audience. So one question is that, can you please elaborate more on the CPAL platform?
Sure. Oh, I can, I'm going to put the link in here.
Thank you.
So I'm going to put it in the answer. So that's great. So, oh, I can't answer it. Okay, so CPAL, if you actually, it's sepal.io, and it's a free platform made available by FAO. And it's basically, we build modules and tools to help people, regular people who maybe aren't, experts in satellite imagery, to help them access satellite data, analyze satellite data, and extract information. So it can be as easy as making a mosaic. So those removing images from clouds in both radar data, which people don't really have access or maybe a lot of experience with, or optical data. So making mosaics, creating classifications, also extracting information from existing data, like Global Forest Watch, for example. We can pull out statistics, all things like that. And it's all provided free with support from the Norwegian government and through FAO. And we're building up a lot of information and documents to help people get started. But basically anybody can open an account, and then you get resources assigned to you. You have an account where you can actually use Amazon instances and so on, and kind of run these analyses. So it's really worth checking out and taking a look. I'll put it initially in the, I couldn't answer the question, but I'll put it in the chat here. Yeah, so there's the CEPAL platform, but I really highly recommend it if anybody's interested to go. And we have webinars and information, lots of videos and so on that we're sharing on to get people to use.
I have another question from the audience. The question is, I'm curious whether data like this could help prevent or control wildfire like those in California recently.
Yeah, that's a great idea. So we do part of so we are developing models, machine learning models to also predict deforestation and degradation, and fire data is an important aspect. So there's several satellites collecting daily, twice a day, basically view of the earth and where things are burning. And so we can already see what has burned previously. And that's also an indicator sometimes of preparing land for agriculture. And we can also potentially predict where fires will occur. So that's a really important issue. And I should mention though, in where we are working, it's the tropical forest. So it's a tropical belt. Fires should generally be limited to savanna areas, and you wouldn't expect them in tropical dense forest. But we see them in tropical dense forest, and that usually means it's human cost. So people are cutting down the forest and burning it and preparing it for agriculture. So so that's where we can kind of have a warning system, and we can see where people are encroaching on the forest and try to mitigate those activities or reduce them and so on.
One probably last question, since we are abusing of you, Aurelie, but since we have plenty of time, so
I would prefer questions to presenting, so it's good.
Yes. Yeah. So we'll squeeze you today, but it's a really very interesting topic. So especially this past year, we have seen all this fire all over the world. So a lot of people were asking themselves, what's going on? Is it related to the climate change, or is it something else? So there was a lot of speculation. So yeah, so one of those questions is, what countries do you observe most deforestation of as of last year?
So, well, globally, I can tell you there's something called the Forest Resources Assessment. I'll put the link in the chat there, and you can actually see what countries report on how much deforestation there is. But globally, we know South America is a major Brazil, major source of deforestation. But in our region, the Democratic Republic of Congo, which is the largest country in Central Africa, is seeing most of the deforestation. Obviously, it's the most area, but there's also a lot of changes occurring. Relative to, let's say, Gabon, which is very highly forested and has a very low population, we see a relatively lower deforestation rate. Yeah, so that's where most of it's occurring, and I think that's where probably people should put most of the resources in the Democratic Republic of Congo. It's probably 1,000 times the size of Qatar, so
True.
it's a lot of huge space.
And as a follow-up on that, when we talk about fire, we talk about probably water also. So we have seen last year. So have you looked at tracking freshwater resources within your program, since you are using the
That's a great question. And I wish we were doing more. Freshwater is tough, especially from space. And in my former job with WWF, we looked at freshwater a lot. And in fact, in these countries where we're working, they discover new species of freshwater fish and biota almost every year. It's completely unknown. The Congo River is the second largest river in the world, and there's just like massive amounts of biodiversity that we simply don't even know about. So we don't, unfortunately, in this project, we don't address it immediately. However, we know that deforestation influences water quality, and so when you have runoff and erosion, then you'll influence the freshwater resources. So it's a related topic, but we don't address it specifically. I wish we did though. But the WWF has been doing lots of work with rivers and especially in terms of what's called free-flowing rivers. So they've been looking at how many dams are being planned throughout the world and how that's affecting biodiversity. And there's a lot of interesting reports on that. I'll put something in the chat. I'll go find it and put it in the chat for you.
Thank you very much. So one last, probably, I don't know if it is a good question or not, but recently I had experience working with people from energy and environment from other field, for example, physical, nuclear physics. Or medicine, yeah. So one of the things that is, people are starting to switch gears. So people who are working using, for example, ordinary differential equation in their way of selecting data or simulating data, they switch to using artificial intelligence or machine learning and probably produce, because we have a flow of big data. And I was a little bit looking at your field, and I have seen that in the past, probably a few years ago, people were using also ordinary differential equation, probably maybe to model this kind of problem. Is this something that is also related to in your field, like people are switching gears from ODE to AE and machine learning and big data?
Definitely, definitely. So a lot of these, for example, I mentioned when I was doing when we were identifying the forest types from satellite imagery, that's all done with machine learning, random forest model, and that's becoming the kind of standard for mapping and for quantifying change. And I will probably do the same now with looking at other variables like distance to roads, distance to non-forest, distance to croplands, buildings. All of those things now are going to go into a new model that will define, try to assess where deforestation is actually happening, with all this validation data we have. So I think that's definitely the trend. And there's even a lot more of deep learning approaches and all of these far more complicated approaches that are being used all the time, also to predict what's going to happen where and next, and can we do something before it happens?
Yeah, very good.
Right.
So with this, I think I will not squeeze you more. So thank you very, very much for stimulating talk. And probably for people who have other questions, maybe I think you are reachable.
Yes.
They can contact you. And thank you very much. And this is the first time I get to know you. It was really very interesting, and I learned a lot of you.
Thank you
so much.
No problem. Great to be here.
Much.
Thanks.
Thank you.